Welcome to another bonus episode of the Techmeme Ride Home, another portfolio profile episode. Today, we are going to talk to one of the most exciting technology companies that we've invested in the Ride Home Fund, and a very timely one considering what's going to be happening over the first half of this year, we believe. We're going to be talking to the founders of Nanome, which is a VR company, but a very specific type of VR company. Actually, let the founders do it. First of all, Keita, introduce yourself.
Hi, I'm Keita Funakawa. I'm the COO and co-founder of Nano.
And Steve.
Yeah, hey, I'm Steve McCloskey, CEO and co-founder of Nanome.
So when I say that it's a unique sort of thing, it is because this is VR, but doing really cool science shit. So whoever wants to take this away, give me the 2-minute sort of elevator of what Nanome does and why it's cool science shit, like I said.
Yeah, definitely. So at Nanome, we're building the ultimate interface for science, starting with molecular data. So it's kind of like, the Jarvis hologram interface that you've probably seen in Iron Man when Tony Stark makes a new atom. But it's real. We use off-the-shelf virtual and mixed reality hardware, and you can download us on the Quest store. And so we make software for those devices. And now at the very, very basic fundamentals, if you strip away a lot of the other kind of features, right, one of the most kind of killer basic things, and as I like to describe it, is it's kind of like those chemistry kits that you might have used in high school, except you never run out of parts in VR and AR. And then on top of that, you can apply some crazy simulation algorithms. You can connect it to supercomputers and see the atoms and molecules wiggle and jiggle. And so, combining that with the latest, in AI advancements and chem informatics, it's a really, really powerful tool for researchers to make breakthroughs in AR and VR.
So this is for chemists, for biologists, for people working with molecules, down at the atomic level or whatnot. So essentially, when you say the Tony Stark sort of thing, or the what's the Tom Cruise movie one, the one where you can move
Minority
with your hands.
Report.
Minority Report, right? So essentially, because again, or not again, but we'll get into how you can literally download this and demo it yourself. You can stand there in virtual reality and you can put molecules together and manipulate them and move things around and do magic with it, essentially.
Yeah, well, science, right? Because through the API, we connect with real scientific force fields and the best practices calculations that are out there. So you could be working with your models very visually and tactfully in VR or mixed reality now, and be interacting, kind of grabbing the molecules, putting them into different positions. But then you could calculate very specific interaction potentials to see how well it's binding, chemical properties. Really all this fun science, chem informatics out there. This is the interface for being able to understand that and spin it up.
So let's get into your backgrounds for a bit. I'm assuming, obviously, Steve, maybe Keita as well, you have a chemical or biologist background, or a scientific background at the very least. Did the idea come from one of those, boy, this is a tool that I wish I had, maybe I should just build it for myself?
Exactly, pretty much. Yeah, I mean, I'd grown up around video games and saw Minority Report and all the cool Hollywood movies. I grew up in North Hollywood, not too far from there, so got a lot of exposure to that type of stuff. And everyone tried VR in the 1990s with a huge helmet on as a kid, and I just wanted a better interface for nano engineering. So I was a nano engineering student at UC San Diego, very new major, basically everything at the nanoscale, dealing with atoms, molecules. Sort of everything below the size of a virus. And I wanted to get hands-on. I wanted to be a real engineer with my atoms and my bits. And it just wasn't possible without, kind of putting on the headset and zooming down virtually and, starting to play with things and tinkering like a real engineer gets to tinker. So, this was my way of fulfilling my dream of being a nano engineer in the way that I saw that it actually had to be. And we found a bunch of other folks in biotech, drug development, that really had the same vision. Like they wanted to be able to see if this drug was binding in the pocket and kind of place it there and see all the interactions occur. So yeah, it's been a very big need for me to want this tool and to see it actually come to life with our development progress. But then we get the same feedback from customers. Yeah, they've been dreaming of this for like 30 years, and now it's finally here.
Yeah, and my background's not really deeply in the sciences. It's a combination of computer science, media, and economics. So my passion actually has been in kind of filmmaking, digital media, photography, and stuff like that. But I also really loved kind of like actual, technology and computer science. I've been coding since when I was in ninth grade, and like doing robotics and stuff like that in high school. And so I was always interested in like the arts, as well as kind of hardcore computer science programming at the same time. And I really didn't know like what I wanted to do in my life until I tried my first Google Cardboard experience in 2014. Mm-hmm. And that's when the metaphor I use from kind of an artistic point of view is like, this is what the painters felt like when they first experienced photography in the 1900s or something, where it's like, oh my God, this changes everything. And also it happened to combine all my passions at the same time, right? It was digital arts. I was able to use Unity and like code up a few prototypes back in the day with Steve, right? And so back in the day, like, so Steve and I both went to UC San Diego, and like we were the only two undergrads that were kind of seriously doing VR stuff on campus. And so, at that time, and even kind of to this day, there's a lot of like zombie shooters and roller coasters in VR. But I was always like, there ought to be a better use for this technology, right? So when Steve was like, yeah, man, like molecules and science, and I'm like, yeah, of course, like Tony Stark, like full on Jarvis, like let's do this, right? So, one fun fact, kind of early on when I first met Steve, speaking of him like wanting to tinker on stuff, like Steve converted his car to run off of vegetable oil in high school, or was it high school, college, right? And so I saw that, I'm like, wow, this is awesome. Like, let's, and like going down to the molecular level, and he was like able to explain it, like what's happening at the chemical level. And then he would just do these hand wavy motions like, oh yeah, like, this part would go like this at the molecule level and stuff. And I'm like, man, if only we could actually see this in 3D and like actually collaborate and talk about this. And he was like, yeah, exactly. Right. And so it's like, it all kind of came together when we met in 2014, 2015.
Right. So that actually leads me to, one of the sort of like founding issues for, you have a great idea, but the technology maybe isn't there yet. And so if we're talking 2014, 2015, this is when, the Oculus Rift is sort of, coming to the fore. Like, is it one of those things where it's like, oh, wait, technology might be ready for this idea? Either if that's part of the founding story, or I guess what I'm kind of poking at is like, is that something that y'all have been dealing with throughout the entire story of this company, which is we know where we want to go and we have to wait for this platform or this technology to get to where we want to go?
Yeah, that's been a bit of it. 2014, I got the Oculus Developer Kit too. It was a 6-DOF headset with no controllers. And there was only so much you could do. So you could, show people that they could, look around a protein. But to try to grab it, we had to use the 6 Sens, like motion controllers, or the Razer Hydras actually. And it was very limiting. It wasn't tracked that well magnetically, and then also it had wires. But it kind of showed the concept a little bit. And then we get the Vive pre-developer kit. Boom. Then like that was a big deal because then we had good hand tracking, good head tracking. You get your hands in there, start grabbing things, and we improved the prototype. And so like every hardware generation that comes out, we get to show like more of the vision becoming real. But yeah, some of it is just waiting. I don't know when Apple's gonna release their headset or other hardware players, but this technology gets better every year and it's not slowing down. And so every time that there's a big hardware improvement, it helps us, it helps our customers, and it definitely gets to that far vision of like this is going to be the ultimate interface for science that everyone's using and developing new technology on.
What's interesting on that aspect, real quick, I wanted to add is
Yeah.
that when we back in the early days on campus, like we did a bunch of business accelerators, startup competitions, that sort of thing, that forced us to ask really tough questions about who's our customer, why are they going to use it, all these types of things. And what we found back in the day, and even to this day, what's fascinating is that our users, like they've been the ones that were pushing for 3D TVs, like buying the green and red 3D glasses just to be able to get an inkling of an idea of the three dimensionality of their molecules, right? And so I feel like it's not necessarily the our software waiting for the hardware to catch up, but it's more, I feel like, the problem and the demand of our end user base that's always been wanting this, that has been kind of feeling kind of the supply side, if that makes sense as well.
Yeah, and it's also this gets into sort of the use case of the technology, which is, you mentioned at the beginning, there's a lot of games on VR and AR and XR and stuff like that, because that seems to be like sort of like the most obvious thing. And then games is a good way into the technology, but people have been intuiting for decades that there is real practical applications to this, and it's I make a lot of jokes on the show about how Mark Zuckerberg wants us to have our meetings in virtual reality with no legs, but this is different than that, because this is like what he's imagining whiteboarding, and plotting on charts and things like that, but taken to the next level, because what essentially scientists are able to do with this, it's sort of like something that they couldn't do before, in the same way that, like, before the spreadsheet was something that like transformed how things were able to be done by people. And this is sort of like that. It's not just you can collaborate. It's not just that you can show your molecule and here's a model or whatever, but like you can manipulate and you can collaborate in real time, and you can do stuff that like was not possible without this technology.
Yeah, they literally have been dreaming of this for decades, and they tried every system. Silicon Graphics back in the 90s. It was like Hollywood using those, and then the scientists trying to get better models of their protein. And then you look at the cave systems, like they had these huge 3D projector on every wall, the ceiling, the floor type of rooms. Multi-million-dollar setups. Just to be able to have that experience where you're with your scientific colleagues, you're understanding the protein binding pocket, you're kind of getting that three-dimensional view. And now this thing is commoditized. For a few $100, you get a VR headset. It's connected through the network, so you don't ever need to be physically located in the same space. You could be anywhere in the world, and you could get a higher quality experience when you're interacting with that molecular data. And like Kata said, when we were at UC San Diego, we got to actually interact with a ton of researchers that were working on everything from cutting edge nanoengineering and sort of biology in that field, but even like computer science and virtual reality. There were researchers that have been doing this for decades as well, working on 3D user interface design, interactions, coding their own VR development programs for like scientific data and like anatomy data. And that was all very experimental research, but we're in the position where now we get to commercialize this type of technology and actually bring it out to all the scientists out there, and hopefully create new scientists in the world as well.
Well, that's a good time to mention that you can try this out yourself if you have a Quest or Quest 2 or what platforms are you on right now?
Pretty much all of them, except for ones that don't have hand controllers. So essentially, like HoloLens is the only exception.
Got it.
As well as like Magically, because they only have one controller. But if you notice, like PCVR, Steam VR, so Index, Vive, right, like all those headsets. We're even on the Pico Neo business store as well. So yeah.
Well, and you can, if you don't have VR rigs, you can also go to Nanome.ai, Nanome.ai, to see videos of like this stuff in action. In the chat, Steve just shared that Balaji also made the same analogy that I did, which I did not know about. He says this is from a few years ago, a tweet where when he used Nanome recently with a colleague, I felt like an accountant that had just seen his first electronic spreadsheet. So great minds think alike there in terms of analogies. But
the context on that was actually during the pandemic. And so we were helping a lot with a bunch of pandemic research. And I'm pretty sure that's how he got exposed. So,
well, okay. Yeah. So who is using this right now? Like, not naming like, clients or things like that, but like, okay. And you can obviously hear, listeners, that Brian doesn't know much about this. One of the beauties of having great LPs in the fund is that, I was able to lean on an LP that is a big time scientist at a big time biotech to demo this stuff with me. And he was like, Brian, invest in this. This is game changing. So explain to me who's using this now and what they're using it for. And right now, today, the actual use case.
Yeah, so real quickly, we actually can share some of the names. One being Novartis, because we wrote a paper with them that we published in 2019. Another one is actually Genentech/Roche that we just did a webinar with in December of last year. And so overall, we actually have over half of the top 20 pharmas as our customers already, as well as a lot of a few dozen like smaller biotechs, not necessarily top pharmas, but biotech startups and folks like that. In terms of the use case and who's using it, we're focused right now on early stage drug discovery. And so there's already kind of a subsect of that called CAD with two Ds, computer aided drug discovery. And so that's pretty much where most of our users lie. And those are like computational chemists, medicinal chemists, as well as structural biologists. So really kind of cross-disciplinary teams that are working on the early stages of drug discovery. But we also have non-biopharma customers as well, including a food and beverage company that we can't name yet, but as well as chemical engineering companies. So even though we're kind of focused as a startup, within our first vertical of biopharma, the applications extend far beyond biopharma because everything's made out of atoms and molecules.
And the idea here is literally building the atoms and molecules and block by block, putting the Legos together. But also, I brought up the Zuckerberg meetings analogy, like, so you can collaborate across teams across the world, and so it's showing off. It's not just showing off what you've been working on, but you can also work collaboratively together, right? That's a key part of this. Is actually the dream of VR made real, where it's like it's not just that distances and borders are erased, but it's also, again, doing the sort of work that wouldn't be possible in meat space because you're able to do the sort of walk around it and take a look at it and make your point and make changes all in real time together.
Exactly. Yeah. I mean, you hold in your hand, kind of point at different locations. Like there's a lot of analysis in the collaboration as well. So like you could totally go in and make modifications and design your new molecule. But now there's so many tools out there that are screening through libraries. You need to understand the top hits and kind of select that even more. So if you have like 1,000 top molecules, you want to get that down to like your top 20 that you actually want to synthesize and test. Just that process of getting the team on the same page to look at all that chem informatics data and see the three-dimensional structures like side by side and make the best decisions. That's done at a lot of group meetings. They have molecule review sessions. A lot of the medicinal chemists will be presenting their molecules and say, hey, these are the ones I generated. These are the different scores and values associated with them. Maybe this is how they did on a physical assay, like tests, like in terms of integrating experimental data and having that as just a data point. So there's all these pieces of information, different AI generated molecules out there now too. But being able to decipher that and really truly understand it as an individual is already hard enough. But then getting the group on the same page where everybody understands it and where to take the project forward, things like that could save literally months of time off of the pharmaceutical development pipeline, just getting everyone aligned on the same page and understand what's working, what's not working, what they need to kill, and what they need to do more of.
Well, and this is another way to think of it for those of us not in these fields is this is almost a development platform too, right? Like you're testing things, you're able to almost like run experiments and like this works, but that doesn't work. Like, and so it's not just, again, a presentation tool. It's also sort of like a development platform for figuring out what does work or getting ideas and stuff like that, right?
Yeah, definitely. Yeah, I mean, just getting everyone, they're in the same space. There's a lot of questions that come up, and like, oh, what if we tweak that? And you can just reach in and tweak it, and like just get the answer to your question immediately. So yeah, that real time feedback's really awesome for the collaborative aspects of the program.
Well, and one of the other things that the LP told me is he was like, this is an amazing time saver. Like, this is one of those things that we can do what used to take weeks or months of back and forth, and we can do it in one shot, and then immediately, break a log jam or something like that.
Exactly. And we've heard stories about that. We've worked on case studies kind of showing the immediate new insight leading to a complete change of either what molecules they were synthesizing or what tests they were running. But yeah, just one little insight could really change your perspective on how you look at these things. Because with science, there's a lot of open questions, and you're trying to come up with some good ideas that you might want to test and validate or invalidate. And if you could, increase the feedback cycle, or I guess decrease the amount of time in that feedback cycle, you could just get so much more good research and science done. So personally, like I want to see better healthcare, better technology in society, and so the more that we can enable people to move quicker, get their drugs to market, develop new different flavors and other industries that we also hop with molecularly. I just want to see more of it. I want to live in that crazy, cool future world, and this is our part to help us get there.
There's nothing worse than going to a doctor's appointment expecting to be the center of attention, and then your doctor seems like they've got better things to do and better places to be. Instead of listening to you intently, asking how you feel, and helping you along, the doctor is just checking the clock. Well, on ZocDoc, you'll find quality doctors who will focus on you, listen to you, and prioritize your care. ZocDoc is the only free app that lets you find and book doctors who are patient-reviewed, take your insurance, are available when you need them, and treat almost every condition under the sun. When you're not feeling your best and just trying to hold it together, finding great care shouldn't take up all your energy. That's where ZocDoc comes in. Using their free app that millions of users rely on, you can find the right doctor that meets your needs and fits your schedule. Book an appointment with just a few taps in their app and start feeling better faster with ZocDoc. Go to ZocDoc.com/Techmeme and download the ZocDoc app for free. Then find and book a top-rated doctor today. Many are available within 24 hours. That's ZocDoc.com/Techmeme. ZocDoc.com/Techmeme. Winter is better with Bombas. Bombas makes thoughtfully designed clothes that make you feel cozy at home, supported during outdoor activities, and just good, knowing that for every item you purchase, they donate another to someone in need. I'm wearing a Bombas shirt right now as I'm recording this, not because I planned it, but because Bombas long-sleeve shirts have become my go-to for the winter. They're that comfortable. I have about a half dozen, so they tend to get picked a lot in the mornings. Every item is seamless, tagless, and luxuriously soft. Merino wool socks and t-shirts are ultra soft, super breathable, and never itchy, making them perfect for winter workouts and cozy relaxing. Are you a winter jogger, a skier, or a snowboarder? Bombas makes temperature-regulating clothing so that you can feel more comfortable doing what you love most. And remember, the cool thing about Bombas is they give back. Socks, underwear, and t-shirts are the number 1, 2, and 3 most requested items in homeless shelters. That's why for every comfy item you purchase, Bombas donates another comfy item to someone experiencing homelessness. Go to bombas.com/Techmeme and use code Techmeme for 20% off your first purchase. That's BOMBAS.com/Techmeme and use code Techmeme at checkout. If you don't mind, let me zoom out for just a second and ask you where you all feel the XR, VR, AR space is at the moment, in the sense that, and again, if there's things that we can't talk about publicly yet or whatever, I get all that, but Apple, we believe, is going to, at WWDC, demo whatever they're going to do. So there's a lot of speculation that even though they're going to come in at the high end, how many people will buy a $3,000 headset if that's what it comes in at? Questionable, but it's one of those things where Apple tends to prove a market, for wearables, for smartphones, for you name it, and so just at a 30,000 foot level, and again, like we've discussed earlier, boy, if the technology is almost ready for what we are imagining or whatever, where do you feel that the VR space is in terms of, are we on the cusp of like a new era? Are we still waiting on mass adoption? What both of you, just for whatever thoughts you have in terms of VR as a space?
You go first, Steve.
It's not the 90s, right? People in the early days in the 2015, 16, would say VR died in the 90s. What are you guys ever doing? And it's the technology was not ready. Like, we didn't have cell phones. And so the fact that we have cell phones and miniaturized technology now, high pixel density displays, that all really led to the current generation of VR and mixed reality. Now I think that putting that together, a cell phone pixel display into a headset with a few lenses is kind of easy to do. So we're seeing a lot more even like third-party random developers like Big Screen VR developing their own headset. So I think that headsets are not going away. The adoption curve has been a little bit slower than cell phones, I think, just because cell phones had been around, 90s, 2000s. People had flip phones and all that. But then the smartphone came out and it was like, oh, this is the obvious thing that we've all wanted. But there were enough people already onboarded to the whole like cell phone idea before getting smartphones. So now it's like, there's a lot of stuff that works in 2D. I still do emails and like a lot of 2D stuff. But for the aspects of, 3 dimensions, molecules in particular, without a lot of 90-degree angles, these things are really hard to analyze. And so I think it's the perfect time for these applications where VR just makes so much more sense. Ours being one of them. So I don't think that that's going away. The developers, the headset developers are getting more into the business enterprise use cases. Like, we've always been, science, enterprise, business, like since day one. And they've been very much focused on gaming. But now I think they're getting outside of the gaming entertainment world, kind of getting it into more business applications. And I think that that's going to just be a no-brainer for businesses that can save money and, make better stuff for their business. Like, if the ROI is there, they're just going to keep going for it. But yeah, like you said, Apple coming out with a new headset, it's going to be kind of a new era of just consumer adoption and awareness. Even if it is 3,000, all the developers are going to get it this round. The next round on the Gen 2, hopefully the price comes down. A lot more people just kind of treat it as a normal thing of like, oh yeah, I got my TV, I've got my smartphone, and I've got my 3-dimensional thing. And whenever I want to do 3D things, like, this is the best interface for experiencing that. I'm excited. I think Apple getting into the game is going to be a huge leap forward for just everyone in the industry to have it be more accepted as a technology that's here to stay, and that's going to just keep getting better with the iPhone 1, 2, 3, 4, 5 type of situation.
Yeah, I'll say some very quick things here. The Google Cardboard was a double-edged sword. Right. I think, for people like me, I was like, oh my God, I know this is where this is going in a macro sense. I need to be a part of this. Right. But for a lot of folks, it was just like, slide in a phone. I guess this is VR. I get motion sick. I don't like VR anymore. Right. And like, Steve and I have demoed countless people who haven't tried, the actual like desktop Oculus Rift or the Vive or even the Quest lately, right? Like, people just think that the sliding into your phone, that's VR. And then we demo these folks, actual VR, and they're like, oh my God, I didn't know it was, like, when you have your hands and we can move around naturally, it turns out you don't get motion sick as much. And so I think that narrative is probably going to be greatly amplified. That's my prediction with the kind of the Apple headset, is that more people are going to be like, oh, this I could do, kind of thing, rather than, dealing with cardboard VR, right? And then the other thing is I think Meta got a lot of kind of heat for like the half-bakedness, if you will, of the Quest Pro of like, is it consumer? Is it actually professional? Like, we don't know. And I think that a lot of it is valid, but I do think that there's a portion which is that, we've seen a tremendous amount of like really, really high-end enterprise VR stuff, which is great for like industrial use cases. You're training fighter pilot jets and stuff like that. Like, great, awesome. But like for us, there is like this kind of, medium where it needs to be a little bit more scalable, like maybe essentially like high-end iPad price point that allows it to be deployed in fleets, right? But still used in an enterprise setting. And I think that like that sort of headsets didn't necessarily exist before the Quest Pro, kind of with the Vive Focus 3, and now it's starting to, I think, catch on with the XR Elite from HTC and stuff like that. So I'm really kind of hopeful and bullish in that direction, if that makes sense.
So to wrap up, again, if you want to see what we're talking about, and you've got VR stuff, search for Nanome, Nanome. There's also the website Nanome.ai. But guys, to wrap up, are there any asks for the audience in terms of if people want to get involved, if people are excited about this and want to contribute? Just tell me anything about, if people are excited about this technology and want to learn more, how they can do so.
Yeah. One kind of quick anecdote here is that a lot of people, when we demo them, they're like, oh man, if I only had this, I would have been a chemist or a biologist. And my reaction is, twofold. One is like, I'm flattered. But on the other hand, it's like, it's not too late, right? Like, buy a $300 Quest and like start learning chemistry, right? And one thing that we didn't really talk about so far is like we have over 250 universities that use Nanome as a replacement for the ball and stick models, right? And so like I've had family members that are like, oh yeah, like I learned what what a hydrogen bond is, like just by looking at Nanome and stuff like that. So definitely like download Nanome, like learn chemistry. It's a great tool to be able to just learn some really fundamental basics. But on kind of the business side of things, if CIOs or scientists, drug discovery researchers, send them our way. We're always trying to, I mentioned we're in half of the top 20 pharmas. We'd love to get into the other half and continue to get a lot more customer traction. So I would say those are the asks from my end.
Yeah, I'd definitely like to see more established biotechs and pharmaceutical companies adopting this. We already have the privilege of working with quite a number of industry, but definitely getting our word out there. But in terms of like long-term future, I think that you could download this software today, go onto your Quest 2 or whatever other VR-enabled device, and start watching like content from scientists, like literally explaining biochemistry and all this stuff. So. Personally, I would like to see more scientists in the world. And so if you're interested in learning, there is a free version to get started, sort of download Nanome, start playing with it. But then, I also want to see a world where there's just more like biotech science going on. So I do think that a lot of people can use this software to make new molecules, kind of share that with people, maybe even in the future have this whole digital biotech economy. Where people are able to, create things, share them with each other, maybe even spin up their own, decentralized companies and sort of things like that to help enable the science. So, I guess I'm a bit of a futurist, but it's not too late. Yeah, you get started even if you don't have a science background. But if you do, I think you'll find it very, very entertaining and mind blowing if you've been waiting for this.
Mind blowing is the right way to end this. Like, this is one of those, the cliche is #proud investor, but like, this is one of those where I'm like, oh man, this is a dent in the universe sort of investment. So I'm super thrilled that the Ride Home Fund is participating with what you guys are doing. Thank you for both of you for coming on and telling us all about Nanome, and it's just really exciting, awesome stuff, guys.
Cool. Yeah. Thanks a lot, Brian. And thanks everyone for listening.